Okay, JDBC, Java Database Connectivity. Probably this is one thing that you will have in every project. Without database, there is pretty much no implementation nowadays at all. And most of the times you come across Oracle database. But if it is Oracle or any other database, WebLogic almost supports 15 to 20 databases inbuilt. Then there are about 15 to 20 which are we can explicitly or manually configure. But any project, pretty much you have a database. Now what we're going to see is how WebLogic helps an application acquire a connection to the database. You will see how WebLogic manages the connection to the data, how it creates a connection, and when an application is asking for such a connectivity, how it provides it. Now this is what actually happens when an application is looking for a database connection. This is the flow that you will look at. So let's just one moment. Okay, here we go. So here is your application. Basically, we have deployed the application on top of WebLogic. Now this application wants a connection to the backend database, which is this one. Now the application is expecting that the connectivity, this thing, be provided by WebLogic application. So now what we're going to see is how WebLogic application servers provides this entire infrastructure. Means what are the various components that this infrastructure, how WebLogic creates it, how WebLogic manages it, and finally when an application asks for such a connection, how this connectivity works. That's what we're going to see. Now the first things first, application first looks up as usual the JDBC. Anything that the application requires, it goes to the JDBC, Java Naming and Directory Interface. Now if I have to explain JDBC in regular words, not in a Java technical words, JDBC is like a notice board. Let's say it's a very simple service provided by your app server. A notice board, an application can come to the notice board, it can look up the notice board, find out the corresponding point of contact for any service. In this case, the one that you are looking at, application is coming to the JDBC. It's looking up for an object called data source, the green box. The data source object is basically the source of this database. Means the data source will have all the details of the backend database you are looking at. Means it will have the details of what database it is, name of the database, what host name it is running on, what is the port number where it is running at, what's the username, password to connect to the database. Means the entire details of the database are stored with the data source. Here the information of the DB is not stored in the application is pretty much it simply asks for a connection. Now once the lookup is done, means on the JDBC, once the lookup is done and the application gets a data source on the back end has what is called an associated connection pool. This one, a connection pool, in the sense, as the name itself says, it's a pool of connections. Now you're looking at a group of connections here, connection 1, connection 2, like that. There are lots of connections. Now each of those connections can provide connectivity to the backend database, to this one. Now one of these connection objects will be given to the application. One of these connection objects, if it is available, assuming we have sufficiently large connection pool, one of these connection objects will be given to the app. Now once the connection object is given to the app, a connection object cannot directly interact with the database. There is no such thing as direct interaction with the database. Anybody who is talking to the database has to do it through a driver. This driver is the one who facilitates connection to the database engine. Now here again what we are actually doing is, so application looks up the JNDI, it gets a data source, this one, then the data source will ask the associated connection pool for a connection object. Every data source has one connection pool associated with by default, not more than one connection pool, only one. We will be allowed to increase the size of the connection pool depending on the load on our application. One application may require only one connection to the database, and depending on the load, another application may require lots of load, lots of requests to the database. So the pool size changes according to the load, and we have to configure it, tune it. Now once the connection object is given to the application starts establishing a connection to the database through the driver. That's the flow. Now what we have to do as an administrator is to configure this part. You will configure the data source, you will configure the size of the connection pool, we will configure the driver, what type of driver it is, these three things. Now to configure it, you'll need two pieces of information. One is the database details itself, means where it is running, what's the IP port, those details. Now those you will get it from the DBA. The other piece of information is the application, means application is looking up the JNDI for a specific data source, means the name of the data source is already hard coded in the application. Let's say here in this case the diagram you're looking at, DS, that's the name of the data source which is hard coded in the app 1. So the developer is going to tell us create a data source with the name DS. Now we're going to create a data source with the name DS. Once we deploy the application on top of the app server, when the application looks up the JNDI, it should be able to find the data source that we have created. Once it finds the data source, the rest of the things are already configured. Rest of the things in the sense, this entire part. Connection pool, drivers, within pool you have connection objects which will let you connect to a database. Now that's a very simple flow of how WebLogic creates a connection to the database, how an application acquires a database connection. Alright. Now all these things we have to configure. Now configuration of this thing is pretty straightforward here. The sizing of this one is little tricky, means we cannot randomly give a size of connection pool. It has to be thoroughly tested, and or we have to do a trial and error method. In a normal production system, the connection pool size is anywhere between 100 to 150. Means there are 100 to 150 connection objects at any point of time. Now 150 may be sufficient or it may be too large, so we need to, let's say, start with 150. You run it for a couple of days, then no issues, then decrease it to 100. Let's say you have a problem. You will see in the logs that could not acquire a connection object, which means 100 is insufficient, 150 is sufficient. So somewhere in between 100 and 150 is your number. So you need to increase it from 100 to probably change it to 120. See if it is working. That's a trial and error in production, but that's not something that's recommended. You should get your numbers correct during the load test. When we are doing the load test, you will be able to identify what kind of load will require what size of the connection pool. That's part of your overall testing strategy. But as an administrator, our job is to create this entire infrastructure and manage it. Alright, let's move on. Now this is the flow as we talked about. Your application is looking up the JNDI. It obtains a data source from the JNDI. Now the data source checks with the connection pool that is associated with it. Connection pool is nothing but a pool of connection. Now if a connection object is available, it gives a connection object. Then application establishes the SQL connection with the using that connection object through the driver, alright, with the, to the database. Now there are a couple of words here. Already we talked about data source. Means data source is the one that is bound to the JNDI. It's an object bound to the JNDI. So if you look at on this diagram, this is your data source. So this is an object. It's bound to the JNDI. This has all the information about the backend database. This also has a connection pool associated with it. This also has a certain driver information. Now all these details are actually part of the data source. Then connection pool is a pool of ready-made database connection objects. One pool is available or associated with each data source. This is wrong here. Each DB, this is wrong. Data source. Then the connection object. Connection objects are basically what a pool consists of. Now connection object is the one that is actually providing the connection. All that we have is, because one connection object would not be sufficient, we are maintaining a pool of connection objects so that we can handle or satisfy multiple database requests. Now the next thing about in this diagram, you will see the important one is the drivers. Now it's not that important, but the way drivers have developed is interesting, and sometimes it might help you troubleshoot certain things.
Yes.
So we're going to look at yes.
This is Kalyan. I
Yes,
just
yeah.
have one doubt.
Yeah.
As you said, how will the application will look up the JNDI, like as you said in the flow, and will it?
It has
suppose
a
the
code
application-
called getup. If you look at this one, hold on. This is the kind of code you will see. Let's say I open up Notepad. The kind of code you will see if you are a developer, you would write something like this. Look up JNDI for data source. This is a code. Get connection. Get connection. This is your database, the Java code that you will write. That's a way of
Okay, so
looking up.
suppose-
This is a function.
So suppose if the application is deployed on some managed servers, not an admin server, so JNDI would be on every server, right? Like inbuilt.
Yes. JNDI is
so-
offered on every JVM.
Okay, every JVM. So if suppose the admin server will also, the application will look up on the admin server also.
No.
When that
No. Application will look up on the local JNDI, which means the local JNDI should have the data source. So as an administrator, we have to target the data source to all the JVMs or all the managed servers wherever we want the application to have this connection.
Okay, but even in their code, they have to write that it should be what we say, it should be related to admin console URL also, right, sir?
Why?
Like I have seen one some troubleshooting issue or there was an issue like JNDI is already existing to the other URL, so they have changed the server name actually to which it has to be connected. That means it's like admin URL. We have like 2 data centers in our environment.
Okay.
Actually, the JNDI was targeted to the first data center, but actually speaking, it should target the second data center. So that was a main issue by which it couldn't look up the JNDI and data sources were not available for the application. So it was going into prepared state. For about 4 hours we tried it and then it got resolved.
So your application is supposed to look up a remote JNDI. That's what you are saying.
Yeah, like a JNDI provider will be there, right, sir? In their code, will they handle that, right?
No, an
Like they,
application can be written in any way. Normally, the application to make it simple or to keep it simple and are
okay.
not to hard code things. What we usually do is when you are writing look up the JNDI, you mean the local
Okay.
JVM.
Yeah, that's what
Local JVM is the default lookup. But if your application requires, so probably what I'm assuming is your application has a
they
remote
have like a
JNDI.
JNDI provider URL, sir. That's what I was confused.
No, JNDI
Normally,
provider URL is your JVM. Even if you say in a regular managed server, that's a JNDI
okay,
provider.
okay.
So your IP
Yeah,
port
that's
of the
what.
managed
But
server
actually,
slash JNDI becomes the JNDI provider URL.
okay, okay.
In
So
your
in
case, what happened was there are some objects which are bound to one JNDI and your application is expected to connect to that JNDI.
okay,
So that's the reason you have explicitly asked the Java program to connect to that JNDI, the remote data
okay,
center in your case.
okay, okay, okay. Yes, sir.
Means
Got it.
when we are creating the data source, I think
Mm-hmm.
somewhere you guys have targeted it to the JNDI provider that you have used. Means the data sources are not targeted to every
Local
JNDI.
JVM, right?
They are targeted to only one JNDI. We are expecting the application to reach that JNDI in every scenario. Probably
Okay.
that's some requirement in your project.
Yeah, that
Yeah,
application is
so
mainly like web services, sir. So that could be the reason, I hope.
yeah, probably what they are doing is they are instead of having it everywhere, they are having it at a centralized location, and the application will look up the remote JNDI, and once it gets a data object, it moves on from that point onwards.
Okay, okay,
It's the
okay,
implementation is little different there.
okay, okay. Yeah, yes, sir. Got it. Thank you.
All right, so let's move on. What we are trying to look at is the drivers. Now, drivers have actually been developed in a chronological way, means probably from 1995 when the connectivity to the database has really picked up fast. Means applications really needed to connect to the database. Means that's the time when Java was actually picking up, 95 90s. When that started picking up, the driver became a very important element about how a how a Java program connects to a database. So there are a lot of types of drivers that are developed, especially to be precise, there are four types of drivers. Means the four type of drivers means they are not developed at a time. It's not something like you have in 95 there were type 1, type 2, type 3, type 4. There are no such thing. In 95 you got only type 1 drivers. They were enhanced, then they called it type 2 drivers. Then they were enhanced further, they were called type 3 drivers, and currently we have what are called type 4 drivers. Now we will so it means current usage is only for type 4 drivers. Type 1 drivers nobody really uses. So what we're going to see is what are these types, how do they actually differ in terms of their implementation. So it's more like a theoretical aspect. So we will be using always type 4 drivers nowadays. Type 1 drivers, if you say, they were the original drivers actually. Means that's when every program wants to connect to a database, so they needed some kind of driver. So if you see it, if there is a Java program, so that's a Java program, they used to use what is called a ODBC driver. There was no JDBC driver at that point of time. This is open database connectivity. Now what we are talking about is Java database connectivity. When you say open database connectivity, what we actually mean is any program. It's not necessary that it has to be a Java program. Any programming language, C, C++, Java, COBOL, take anything. Any of those programming languages can use this commonly available ODBC connectivity code, and they can connect to a backend database. Now, obviously, this is a generic code, ODBC. It's not optimized to perform better. It simply is created to provide a connection to the database. It may not provide a better performance, but those are the ones that actually were available at that point. So what we have here is you have ODBC code, which is this one, alright, and then there is a Java program which will write the implementation part to connect to the use the ODBC, connect to the database. So because there are two elements here, one is from the Java program here, other one is ODBC, we usually call it a bridge driver. So the first type of drivers are called bridge drivers. The bridge drivers have used ODBC code. Now the ODBC code was provided free of cost by Microsoft. Even now it does. So Microsoft is the creator of the ODBC connectivity code, and any program can use ODBC connection to connect to any database, not just Oracle database. These were the original drivers which were used to connect to a database. Now once they are done, they were being improved, just to offer a better performance, a better connectivity. Then the type 2 drivers arrived. Type 2 drivers, it's a simple upgrade kind of thing. Earlier you used to use the code provided by Microsoft. Now what we are doing is, instead of using the ODBC code, we are using the code provided by the vendor itself. Now if you see Oracle database, Oracle started providing a code. A code is written in most of the times in C. So you got a native API, which is a vendor provided piece of code. Instead of what we have ODBC earlier, now we have the native API. Then your program part really remains same on this side. You will still write the connectivity code to the native API using the vendor provided driver. Alright, so these diagrams may not be really accurate, but we are getting a general idea of what actually happened. So initially we were using ODBC. Our program will use ODBC to connect you to the database. So we had a bridge, type 1 or bridge drivers. Now instead of ODBC, we replaced ODBC with something given by the database vendor. If we are using Oracle database started giving you a piece of code. Now that piece of code we have used instead of the ODBC code. Now that's usually called the native API. Once you started using native API, they're called type 2 drivers. So type 2 drivers are basically, they don't use ODBC anymore. They got a little bit better performance, if not too much. So every vendor started giving the native API, Oracle, DB2, Sybase, Teradata, anybody. Then this has improved further. Means during the next years, it moved on, it improved further. We came to a stage where we have type 3 drivers. Now the type 3 driver, if you say, it's a modification of type 2. In a sense, let's say you got a bank, a small bank at that point, where there is a central database and about 100 employees in the bank. Now most of the applications during type 3 are client server applications. Means there is a centralized server. The client is installed on all your desktops. Now in the scenario that I'm giving, all 100 employees sitting in your bank premises have an application installed on their desktop. Now that application will connect to a database which is centrally located on a server. Now when such a scenario is there, the driver, which is type 2 driver, if we are using, the driver has to be installed on all the 100 desktops. Now if there is a maintenance tomorrow or an upgrade tomorrow, we needed to upgrade on all the 100 systems. So that used to be kind of labor intensive, so you have to have skilled IT person to do that, and there are problems with your upgrades, all that stuff. So what was done was, instead of installing the driver on the desktop of all the 100, let's move the driver into a common machine. Now that machine at that point of time used to be called the middleware component. So type 2 driver, you have the driver on all the 100 desktops, but in type 3 you don't have the driver on all the 100 desktops. You have it on a centralized server. A centralized server used to be called middleware server. Now middleware nowadays has a complete different meaning, but at that point of time, probably we're talking about 10-15 years before, the middleware component is basically the server that hosts the driver. So now instead of having the driver everywhere, we have the driver on a centralized server. So the client will connect to the centralized server or middleware server first, which will let you connect to the backend database. So now this type of driver where you have a common middleware component is called a net driver, because we are using a network kind of thing. So it's either called network driver or it's called a net driver, or in a very generic sense it's called a type 3 driver. Then the improvements have started coming in, and then you finally have today's driver, what is called a type 4 driver. Now by the time we arrived here, now the drivers themselves are written in Java. They're not written in C anymore. Now because they are written in Java, obviously if you are using a Java program on the other side, so what happens is, here you have a Java program, your driver is also written in Java. So obviously there is no bridge kind of setup here. The entire thing you are looking at is a homogeneous setup from top to bottom kind of. So because of this reason, it's called a pure Java driver. Everything is Java here. So it's called a pure Java driver. So a type 4 driver, it is called pure Java driver. Another thing is, it's called thin driver. The reason is, a thick driver usually, as opposed to thin, obviously you will have something called thick. A thick driver has multiple technologies, or it's heterogeneous. Means one program, our program could be C, then your driver is written in Java, then the implementation connectivity, that's a thick program. Whereas here everything is Java. So either you call it pure Java driver or you call it a thin driver. Now these are the drivers that we are going to use currently, and all the databases, all your projects are currently using type 4 drivers. So you have type 1, 2, 3, 4. Currently the ones that are being used are type 4 drivers. Type 1 are bridge drivers, type 2 are API drivers, type 3 are network drivers, and type 4 are pure Java or thin drivers. Alright, so you will be depending on implementation and programs compatibility, either you will be using a type 2 driver or type 4 driver. If we don't know what driver we want to use, we will use the most advanced, the type 4 driver. And WebLogic comes with certain for certain databases, WebLogic comes with these drivers inbuilt. Means when we install WebLogic, it also has installed these drivers for the most popular databases. I'll show you what are the databases that are by default supported. For those databases, the type 4 driver is already installed. We can simply choose from a drop down. So this is a summary. Type 1 is a bridge driver. So you got basically a ODBC code provided by Microsoft plus a JDBC, so Java program. Then type 2 is your native API. It basically gets provided by the database vendor, Oracle, IBM, or anybody, whoever you are buying the database from. Then type 3 is where you have moved your drivers onto a centralized server. It's called a middleware host, so it's called a net driver. or network driver, anything you can call it. Type 4 are your pure Java drivers. You also call them thin drivers. And these are the ones that are being currently used. Now, apart from these things,